Hello everyone, in this video, the world's largest airport, Beijing Daxing International Airport. Beijing Daxing International Airport is one of the most modern international airports in the world. US President Joe Biden can't help comparing it with Chinese airports when he promotes infrastructure.
I got in trouble because he said if I took you into O'Hare Airport blindfold in the middle of the night and took you into one of China's airports blindfold in the middle of the night and said, where are you, China or the United States? You'd probably think the Chinese airport was ours. It's so modern, so different.
Beijing Daxing International Airport is a huge airport in scale, which can be said to be the benchmark building of the world airport. With a combined area of 1.4 million square meters, it has the largest terminal in the world. The terminal is 50 meters high, has a total of 7 floors and a floor area of 780,000 square meters. The foundation is the world's largest single concrete floor, with a spectacular star-shaped roof made of 57,000 tons of steel. Some people may not understand that Beijing, China already has the capital international airport, so why should we spend a huge sum of money to build the Daxing International Airport? The reason is simple. Beijing is the capital of China and one of the biggest cities in air passenger demand in the world. But the only capital international airport is already at full capacity, simply unable to meet the needs of passengers. To solve this problem, China has had to spend huge sums of money to build the Beijing Daxing International Airport. Construction of the airport began in 2014 and was officially put into use at the end of 2018. It was originally scheduled to last for 5 years, but the actual construction process took only 3 years and 9 months. To build such the largest airport in the world in such a short period of time, perhaps only the Chinese people can do it. As we mentioned earlier, the star-shaped roof of the terminal building is assembled from steel bars, with a total weight of more than 57,000 tons. How did the Chinese engineers solve the technical problems with such a heavy steel structure roof? In the eyes of Chinese engineers, no difficulty cannot be solved. Such a technical problem, Chinese engineers only used 8 C-pillars to solve the technical problem perfectly. For Beijing Daxing International Airport, the roof of the terminal building is not just a structure, it is more like an iconic artwork full of national pride. The structure of the roof is extremely complex, mainly composed of multiple flowing curves. Because the interior of the airport needs wide and unobstructed space, too many pillars cannot be used in the design, because if there are too many pillars, the intricate internal structure can disturb the sight of passengers, which may lead to the chaos of the terminal. So Chinese engineers used 8 C-columns to support the entire roof structure of the terminal. This design is the engineers from the design of the Roman Gymnasium. We see that the entire roof structure of the Roman Gymnasium is not supported by columns, and it has reached a staggering 130,000 square feet, the largest steel curved roof in the world. The frame of the entire roof is assembled from over 12,000 beams and over 3,500 spheres. It mainly uses the principle of the triangle with stability to design. Engineers only need to attach the steel columns together to get a complete pyramid chain. Through the length of the rod and column, different bending structure modeling can be designed. Such a design not only reduces the materials used in construction, but most importantly can greatly reduce the weight of the roof. The roof construction of Beijing Daxing International Airport was also designed using this principle. The difference is that the roof of Beijing Daxing International Airport uses more than 750,000 parts of different sizes, and each part is accurately calculated and manufactured through a computer. Different parts, all with a QR code paste, just through the mobile phone scan, engineers will know where the steel rods and sphere are used. This makes the engineer very efficient when they assemble it. When the shape of the terminal is determined, the complex space structure can be constructed. Engineers built 8 giant C-columns and then divided the steel roof into several areas. These steel columns and spheres are first welded together on the ground. The interface of each part must maintain the accurate positioning of the error within 2 mm, otherwise, it may cause the instability of the whole steel structure, resulting in the collapse of the whole steel structure. After the whole steel body structure is assembled, the whole steel structure is finally lifted through the crane. When all the steel structures were installed in the designated location, the engineers welded them into a huge roof structure, so that the airport steel structure roof frame was completed. After the steel frame is built, engineers have to install cladding inside, not only for beauty but also to reduce the noise of the aircraft. Above the roof, engineers install more than 8,000 pieces of glass and 40,000 pieces of the aluminum wrap. Because of the high transparent glass on the roof, the lighting of the whole airport will be very good, and the light bulbs used in the airport are almost all smart light bulbs, which can adjust the brightness of the terminal according to the brightness of the natural light in the airport. After this series of processes are completed, this super building called one of the 8 wonders of the world appears to us. That question came over again. Chinese engineers have only used 8C columns to support more than 5,700 tons of steel roofs. Will the entire airport collapse in natural disasters such as earthquakes? For this problem, smart Chinese engineers have long designed earthquake resistance into account. The seismic design of the overall structure of Beijing Daxing International Airport is mainly inspired by the Italian ancient Roman columns. As we all know, Italy, located in Europe, is one of the most seismically active regions on Earth. After more than 2,000 years, the stone pillars of the Parthenon are still not standing. What architectural principles were used when they were built to make them amazingly resistant to earthquakes? With this question in mind, the engineers decided to go to the Parthenon to explore. Through field trips, the engineers found that the building was not fixed with any mud and sand. Just a piece of stone columns neatly stacked together. To explore the mystery, the engineers found the foam and wooden boards for field testing. First, glue the foam block to the board and shake the board to simulate the situation of the earthquake, but it failed. The engineers concluded that the force to the top of the structure caused the entire simulated structure to collapse. Faced with this situation, the engineer immediately changed another way of thought. This time, the unbonded foam is superimposed in turn, and we see that under the action of repeated applied forces, the simulated structure still does not collapse, which is better than the seismic effect of the first one. Engineers were soon inspired to discover the principles of damping and isolation systems. This principle can improve the overall seismic resistance of the building. So the design of Beijing Daxing International Airport also uses a similar principle. But the airport is much larger than the Parthenon. Therefore, engineers must innovate on the principles of damping and isolation systems to ensure that the overall structure of the terminal still stands firm in the event of natural disasters such as earthquakes. Therefore, engineers installed vibration isolation dampers on all 8 C-pillars that support the entire steel roof. When an earthquake occurs, there are generally 2 kinds of motion, vertical motion and horizontal motion, among which the horizontal motion is more destructive to the building. These dampers consist of a stack on which 30 rubber and steel sheets are mounted. When an earthquake occurs, the building can be moved back and forth in a horizontal position. In this way, the energy generated during the earthquake is dissipated. Under the protection of dampers, the overall terminal structure of Beijing Daxing International Airport can withstand earthquake disasters of more than magnitude 9. Beijing Daxing International Airport is a practical and strong and unique shape of the airport. The golden appearance brings passengers a full sense of science and technology, and the large area also meets the large flow of people in Beijing, which is a very practical construction project. Today's China is experiencing the rise of great power at an astonishing speed. Chinese engineers are using their persistence, their efforts, and their methods to continue to write the remarkable Chinese miracles and demonstrate the extraordinary power of China. Watch this review of China's project to build the world's largest airport, and tell us what you think. Enjoy!